Hi, this is your Professor Sudha Koluthuparambal, Section 8.4, Confidence Interval for a Standard Deviation. In this section, you are going to learn how to find the critical values of a chi-square distribution and how to construct confidence interval for variance and standard deviation of a normal distribution. The methods of this section apply only for the samples drawn from a normal distribution. If the distribution differs even slightly from the normal, these methods should not be used. When the population is normal, it is possible to construct confidence intervals for the standard deviation or variance. These confidence intervals are based on the distribution known as the chi-square distribution. We usually denote the chi-square writing like that. This is like a kind of like an X, but one is in the like a curly like that. So this is a Greek letter chi. We pronounce this like chi. There are actually many different chi-square distribution, each with a different number of degrees of freedom. The diagram represents the chi-square distribution for several different degrees of freedom. There are two important characteristics for the chi-square distribution. Chi-square distributions, they are not symmetric. They are skewed to the right. And the second one is the values are always greater than or equal 0. That means they are never negative. Now let's see how to find the critical values using the chi-square distribution. So we need to find critical values of 95% confidence interval with 10 degrees of freedom. So this is 95%. So the sum of the shaded part, these two should be 5%, right? 5% means 0.05. And we need to divide by 2 to get the area of each part. So 0.025. So this area is 0.025. This area is also 0.025. This is the lower critical value. So it has 1 minus 0.025, that is 0.975. It has that much area on the right side of this. So the lower critical value we can denote by chi-square 0.975. It has an area of 0.975 to its right. And the upper critical value, that is this one. So it has only 0.025 to its right. So chi-square 0.025, and it has an area 0.025 to its right. We can find the critical values from the chi-square table at the intersection of the row corresponding to 10 degrees of freedom and the column corresponding to 0.975 and 0.025. So the critical values are 3.247 and 20.483. Objective 2 is constructing confidence intervals for the variance and standard deviation of a normal distribution. S square is the sample variance from the random sample of size n. Then the confidence interval for the population variance is, and the confidence interval for the population standard deviation is, take the square root of the above formula. the number of degrees of freedom is always 1 less than the sample size. In this example, the compressive strength of 7 concrete blocks are given. So n equals 7. And we need to construct a 95% confidence interval for the population standard deviation. So we are going to use this formula. So we need to replace this n, s and chi-square with the values. So since we know n equals 7, n minus 1 will be equal 7 minus 1, 6. But we don't know the variance. We don't know the critical values. So first we will find the sample variance. So either you can use this formula or you can use the TI-84 calculator. Enter all these in the list, then use stat calc, then 1 var, and find the standard deviation. And square that to find the variance. Now find the critical values. So 6 degrees of freedom, critical values are 1.237 and 14.449. And use the above formula to find the confidence interval. So replace n, s square and the chi-square using these values. So the population standard deviation is between 33.48 and 114.44. Now interpret the result. We are 95% confident that the population standard deviation of strength of concrete block is between 33.48 and 114.44. Remember that methods of this section apply only for the samples drawn from a normal distribution. If the distribution differs slightly from the normal, you cannot use this method. So in this section, you learn how to find the critical values of the chi-square distribution and how to construct and interpret the confidence intervals for the variance and the standard deviation of the normal distribution.